Hello and welcome to the Computing Conversations column. This column is from the October 2016 issue of IEEE Computer and is titled The Living Computer Museum. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column and I'm Charles Severance from the University of Michigan. The unique goal of the Living Computer Museum in Seattle, Washington is to keep old computer technology powered up and ready to be used by patrons. Instead of sheltering its rare artifacts in climate-controlled glass cases, most of the computers at the museum are turned on and accompanied by a user manual to read, a chair to sit in, and a keyboard to type on, so you can explore what it was actually like to use computers from a bygone era. The museum is supported by Paul Allen, who's the co-founder of Microsoft, as well as others, to make sure that visitors can experience what it was like to use technology as it emerged and developed over the past 50 years. Although the museum does collect, catalog, interpret, and display historically significant computer technology, it spends most of its time maintaining and repairing that technology to keep it running. According to museum librarian and archivist Cindy Moya.
A lot of museums, computer museums, that their artifact is like a special holy thing. You put it away carefully and then you don't use it for anything in particular. But this is a really crossover between a parts lab and a museum. So the items that are in the collection that are findable are usable. So we will use them to replace things in the computers.
This means that it's important to keep track of the items in the collection and the parts within those items when they are scavenged to fix another computer. Sometimes it's necessary to re-engineer an element of a computer when a replacement part can't be found or if the original part is too expensive or has reliability issues. For example, there are a lot of Digital Equipment Corporation systems at the museum, which have the same power supply. As originally designed, the power supply was inefficient, needed to be repaired regularly, and was expensive to maintain. According to the museum's senior systems engineer, Keith Perez,
this particular module, there's 56 of these in various machines all over. All our DEC machines. It was a standard module the DEC produced. The problem is replacing these capacitors every 10 to 13 years because they wear out. And so what we decided to do was come up with a contemporary design that basically fit in the same form and function, and then they basically made it into this 3D printed module. So there's no solder connections anywhere. It's highly reliable. This is of a size that basically if it degrades over time, we don't care so much. And then this is a mill grade power supply module, and then this is the rectifier. And we also found that the connector that DEC had used was underrated, and so we replaced it with a modern type that actually has a higher rating. So basically built a bunch of these, and they're all in the machines now.
And how do you even figure out that that's the problem that you need to solve?
Well, when I first got here 13 years ago, we had to rework a bunch of these. So we bought capacitors at the time, and it came up like 10 years later. They started failing again. And so we said, well, we counted the number of modules we have. It was like, oh my God, it's going to cost us an arm and a leg. Not only that, these guys, the ultra large ones, aren't available anymore, or they'll build them spec to spec. But so you're going to spend a huge amount of money. Now this entire module costs us $350, and that's once. And these things are mil spec. They're guaranteed for 40 years.
Solving a problem like an unreliable power supply is a fun engineering challenge. You have to figure out how the part works and then find a better way to do the same thing using modern technology. Keith said the new DEC power supply turned out to be far superior to the original power supply in terms of its power consumption.
By using this new module, this is a linear supply, it has about a 15% efficiency. This has a 90% efficiency, and so we automatically saved 10 tons of air conditioning that normally would have gone in out as heat. So the machines run cooler, they fail less often, and we're not repairing them as often.
The LCM's goal is to make these old computers reliable so they can run in continuous production 24 hours a day, 7 days a week. According to Cindy,
that we are working to restore these computers is one of the things that makes it special. And the other thing is that we make them available to people on the exhibit hall and also online on the internet, people can log in, get accounts, and try out different operating systems that are really running on the real computers.
It might be a good idea to review your BASIC programming before you come to the museum, as you'll need to know BASIC to use many of these early mini and microcomputers. My favorite was writing BASIC on a PDP-8 mini computer with a real working TDY-33 terminal. I also wrote some BASIC on a Heathkit H19 mini computer, and I wrote a Hello World C program on an early Sun workstation. But with all the computers available, the most enjoyable exhibit for me was the IBM 029 key punch. Feeding blank cards, adding 7 spaces for Fortran, and then typing characters represented by punched holes in the cards took me back to when I was first learning to program in the 1970s. The IBM 029 was a joy to use back then, and I loved reliving my early experience with it. Cindy says this is the typical reaction when programmers visit the museum.
You have different age groups. Older people come, and they often have a feeling of nostalgia. They will have used this stuff, and they will express delight. Oh, look, I had one of those. It was so exciting. Ooh, wow, I remember that. And they look back at the days when computing was really quite difficult. You'd have to use cassette tapes to load your programs, or interact with them with a teletype.
For younger tech-savvy visitors, Cindy says that the computers are an important history lesson.
Some of it is to demonstrate how far we have come in a very short period of time, from these giant supercomputers to our telephones, which have more computing power than is in the entire museum.
If you're in Seattle, plan to stop by the Living Computer Museum to see and touch the wonderful artifacts. But be warned, if you sit down and start to use some of these wonderful old computers, you might find yourself spending an entire day at the museum. This column is from the October 2016 issue of IEEE Computer and is titled The Living Computer Museum. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column, and I'm Charles Severance from the University of Michigan.